Hello, welcome to Fun Python Projects. In this video, we'll be looking at how to find prime numbers using Python code. And of course, if you're not new to math, you already have an idea of what prime numbers are. They are simply natural numbers that are greater than one. First of all, they are greater than one, and they have no positive divisors other than one and themselves. Okay, so they are the fundamental building blocks of arithmetic because every number can be expressed as a product of primes. And that is the concept known as the fundamental theorem of arithmetic, that every number can be expressed as the product of primes. Like take 9, for instance, you can express 9 as 3 times 3. Take 30, you can express 30 as 2 times 3 times 5, So 2, 3, and 5 are all prime. So examples of prime numbers include 2, 3, 5, 7, and 11, 7, 11, 13, and so on, with 2 being the only even prime number. So 2 is the only even prime number. So prime numbers play a vital role in various fields such as cryptography, number theory, and computer science, where their properties are used to secure data, generate random sequences, and design efficient algorithms. So prime numbers are really important in our day-to-day existence, of course. So the first thing we want to do is we want to see how a Python code helps us to see whether a number is prime or not. Okay, so you have Python program to check if a number is prime. So you have num here. So num is a variable that it's anywhere you have this input thing, this is going to prompt you to to supply something, and it is expecting you to supply only integer. So you have integer. Input means it will prompt you, then int means that it has to be integer. If it is not integer, it will not accept it. So by the time you supply that number, so it's now tested that if num is greater than 1, first of all, that's the first condition. And then for I in range 2, 2 is the minimum up to the integer part of the square root of the particular number you type, because num raised to power half is like square root of num, whatever you would have supplied here. So that one added to that. So then if num modulo I, that is the modulo division, if you divide that number by the position it takes, right, and it gives you 0, then it means the number is not a prime number. Then you can stop there, all right? Else, you can go ahead and say print the number is a prime number. Once it doesn't follow this law, and then that can be printed, okay? So let's go ahead now and write and run this. Let me just impute 7. So it just goes to the top. So 7 is prime, obviously. Let me go 47, big number. 47 is prime. Sometimes some numbers look like they are prime, but let me see. Okay, 39 obviously is not prime, right? And so on and so forth. Okay, so the explanation here is that we only check divisibility up to the square roots of num for efficiency. Okay, so the else after the for loop executes only if the loop completes without break. So once you discover that the number is not a prime number, it just breaks. Okay, and then you just go ahead and have that the number is prime. But if not, it continues operating. That's one thing. What if you want to know the prime numbers within a range? So you want to find all prime numbers in a given range. So here we have a Python program to find all prime numbers in a given range. So you have the lower and the upper. So you need to give us a range. So impute the lower range, impute the upper range, and then you want to print numbers between prime numbers between lower, whatever you supply as lower, and upper are. Then I have for num in range lower, comma upper plus 1. Okay. So if num is greater than 1, right? So for I in range 2, like the test we did before, if num modulo 1 is equal to 0, then break. Otherwise, that's else. Now you print the num. So let's see. So this is now an iterative process. Now you keep trying the numbers until you get what you need to get. Okay. So let's go. So I do this now. So the lower range, let me say I want to find all the prime numbers between 1, all right, and 100. So between 1 and 100, prime number between 1 and 100 are 2. Oh, okay. Okay, I was wondering. So we have all this now. So 2, 3, 5, and the last one is 97. So 97 is a prime number like that. Okay. I want this to go. Okay, no problem. So these are the prime numbers between 1 and 100. So how many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 25 prime numbers from between 1 and 100. So explanation, the loop, so the loop goes through each number in the range. For each number, we test the divisibility up to its square root. If no divisor is found, we print the number as prime, okay? So then the last thing we want to do is to see, we want to have an optimized prime generator using the function. Why is this not living here? Okay, let me just leave it alone. But I expect it to go away. Or okay, good, it's gone. Thank God. Okay. So optimize prime generator. Now, so we want to declare a function to do this. So you see the main working unit of this whole thing is this part, this test, so you try up to square roots and all that. So you have define is prime n. So it means to run this code now, you just need to type prime n. Okay, yeah, okay, this function works inside of that. Okay, fine. So define is prime n. If n is less than or equal to 1, return false because we don't need anything less than or equal to 1. So for I in range 2, integer, integer n raised power 0.5 times plus 1. So if n modulo I is equal to 0, return false. That means it is not prime. So then otherwise, it return true. So then we define another function, primes in range. So maybe you want prime within a range, start, end. So you now return n for n in range, start n plus 1 if it's prime. So this is now based on what is happening here now. If it's prime, n, and then a possible usage is you want to find the prime numbers between 10 and 150. So you run this now, and then it gives us all the prime numbers between 10 and 150, like this. So maybe I want to find all the prime numbers between 1000, okay, and 2000, like this. So here we have them, quite a lot. So 1999 is a prime number, 1423 is a prime number. Okay, let me do something. Since we are in the 21st century, so I want to do 2000 to 2000 to 3000 to know the years in this century that are prime numbers. Okay, 2003 was the prime number, and the last one in that series is going to be 20 2020 2999 is also a prime number, and so on and so forth. 2005 obviously is a prime number. So so before 2025, the last prime number we had, the last prime number year we had was 2017. The next one will be 2027, followed by 2029. And after that, it takes another 10 years. Okay, let me even look at the years. 2003, 8 years after we had 2011, 6 years after we had 2017, 10 years after we had 2027, then 2 years after we had 2029, 10 years after we had 20, we will have 2039. Then this is like how many years now? This is like 14 years after we have 2053, and so on and so forth. So that's how this goes. All right, so with this, I come to the end of this interesting video talking about how to find a prime number. So if you are in that space where you need to know if a number is prime or not, this can help you. If you want to know the prime numbers within a range, this can also be of great help to you. All right, let me know how helpful this is for you. And if there's something else you'd like me to try, feel very free to let me know. Okay? So if you have subscribed to this channel, I thank you so much for that. If you haven't, of course, you don't want to keep missing out on the great content I have going on here. So what do you have to do? Just click on subscribe and get subscribed. And of course, hit the notification bell so you can always get alerted each time a new video is released. Having done that, you want to take it a step further if possible to become a member of the channel, and that gives you some special privileges. Okay. Ultimately, don't forget to comment, like, share, so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.